All right. It's called high roller. It's a Ferris wheel in Las Vegas. Has a diameter of 156. Actually, the actual diameter is a little bit bigger, 158 and a half. But where the people are actually sitting, I think it's a little bit less. So 156 meter. Assume that the 60 kilogram passenger is seated in a chair inside cabin of a high roller, which is revolving at constant and unusually high rate of 2 RPM. It's 2 revolutions per minute. It's in fact a lot less than that. What is the normal force on the person from the seat at the lowest and highest points of the wheel? When the person is here and it's rotating like that, what is the normal force on the person? And when the person is here, what is the normal force? And then it says, what is the magnitude and direction of the net force on the person at the midpoint between highest and lowest point on the way up? What is that at the midpoint on the way down? What is the magnitude and direction of the total force from the seat on the person at the midpoint? And at what rate in RPM would the passengers feel weightless at the topmost point? So there are a lot of good questions. So we start with, what is the normal force on the person from the seat at the lowest point? And then we do highest point. What do you think? At the lowest point of the wheel, let's say right here, sitting on a chair, and it's going at some speed, v, or angular speed, omega. Constant speed, of course. How many forces are acting on the person? At that lowest point.
I just count 2. Normal force.
Normal force and the weight. All right. So I can draw a free body diagram, like right here. X and Y. How many forces? We said that W, which is downward, and normal force, which is upward. Is there acceleration?
Yes.
Constant speed, but we're going on a circle. So there's acceleration. Which way is the acceleration? Which way is the acceleration of the person? What is the direction of acceleration?
It's going upward, right?
Why is it upward? Yes. It's
It goes to the
toward
center.
the center.
Toward the center.
Always toward the center. So the acceleration is up, but I don't put it here, I put it on the side. Acceleration is up. And what is the magnitude of acceleration?
V squared over R.
V squared over R. R is what? The radius of the circle. So if I write sum of fx equal to max, what do I get? I get nothing, right? There's no x component of force, and there's no acceleration and acceleration, so it doesn't give me anything. But I can write sum of fy equal to ma1. What are the y components?
Normal force and weight.
N minus mg, right?
Mhm.
Y component of normal force is its magnitude. Y component of W is negative of its magnitude. We add them together, according to this, equals to mass times magnitude of acceleration, because this up, which is v squared over up. Right? So we can find for n. We can solve for n. N is equal to, it goes over from m times g plus v squared over r. But what is r? What is v? It's going at 2 RPM. If you want to find normal force, we need to find v. We have r, we have g, we have m. What is v in this case? The speed. What is 2 RPM means?
2 revolutions per minute.
2 revolutions per 1 minute, right? Means v is twice 2 pi r in 60 seconds, right? So that's 4 pi times r, which is, how much is r? 156 the diameter divided by 2. It's right, 78 divided by 60. What is that? Pi over 15 times 78.
16.3.
16.3. What's the next
4.
digit? 3, 4
Yeah, 3/4.
meters per second. What is v squared?
So,
Just divide, multiply by itself. The square becomes
267.
267 meters squared per second squared, because we are going to use that again. All right, let's divide by r, which is 78, multiply by, add to g, and then multiply by the mass of the person. We get the normal force, right? So normal force is equal to 60 kilogram, 9.8 plus v squared. V squared is 267 divided by r, which is 78. We get some 700, I guess.
793.
793. This is the at highest point, the normal force at lowest point, sorry. Lowest point. What about highest point? What is different at the highest point?
Acceleration and negative.
The acceleration is downward, yes. So we can flip this. Everything looks the same. At the highest point, this is the three-way diagram. You see normal force, and the weight, and the acceleration is downward. V squared over r. So if I write this, get n minus mg equal to m times negative magnitude of acceleration, right? So there's negative sign here. Negative sign goes here, negative sign goes here. So we get n equal to m times g minus v squared over r. That would be 60 times 9.8 plus minus 267 divided by 78. 60 times 9.8 minus 267 over 78. That becomes what? It's a smaller number.
Whoa, I got a negative.
No, that shouldn't be negative because 267 over 78 is not 9.8. It's not bigger than 9.8. Here.
382.61.
Yeah, 382.6.
62.
No, that doesn't matter. It's just 383 would be enough. Newton. All right, so that's for the normal force at the highest point. Force highest point. Now it says, is there any question? What is the magnitude and direction of the net force on the person at the midpoint between highest and lowest point on the way up? Means around here. And it's going that way, around here on the way up. Let me draw another one. Oh, I didn't need to draw another one. At any rate. So, this is the wheel again. It's going this way, let's say, and at this point, and it's going up. What is the magnitude and direction of the net force? You know the direction? The direction, is it normal force it says? What about net force it says? What is the direction of net force? Not normal. Everything, all the forces together.
No, it'd still be that. Right?
Yeah, and the acceleration is that way, isn't it?
Well, because of the frictional force.
Whatever it is, whatever forces acted on the person, because the acceleration is that way, net force is that way. It's Newton's law in vector form, F net as a vector is equal to mass times acceleration as a vector. So it means that this is a scalar, it doesn't change the direction, right? The net force is in the direction of acceleration. So if the acceleration is this way, toward the center, the net force is that way. Right? But what is the magnitude? The magnitude of the net force is equal to mass times magnitude of acceleration. What is the magnitude of acceleration? We're going at the same speed, right?
It's a
V squared over R, right? So F net magnitude is equal to M A magnitude, which is m times v squared over r. V squared over r, sorry. Right? And we have these numbers, so that is 60 times v squared, which was, what was that? 267 divided by 78. This is magnitude of F net.
205.38.
205. Right? So, that's the answer to B. What is the magnitude and direction of the net force on the person at the midpoint between the highest and lowest points on the way up? What is that at the midpoint on the way down? Yes, when you go this way,
Just the opposite.
the opposite. What is the magnitude? Again, toward the center,
And that force is the same.
the same magnitude, right?
It's the same.
So it's the same, basically. D.
Can I ask you the magnitude and direction you just put towards center?
Yes, it's always toward the center.
That's how you write it? You say towards center?
Yes.
Oh, yeah.
Yes, toward the center. Oh.
Yeah, would you write it to the left?
Oh. This, you mean, yes, this is F net, this much toward the center.
So for both answers, you write towards the center?
Yeah. But, you know, if there's a figure, ask you to left or right, you know
Okay.
which way the center is, right?
Yeah.
It's always toward the center. All right. Now it says, what is the magnitude and direction of the total force from the seat on the person at the midpoint? Let's say at this point, that's on the way down. How many forces are acting on the person? So let's do this. Part B.
3? Still
Which ones?
friction, and,
Alright.
normal force,
Normal force.
and gravitational, or weight, or
The weight, yeah. What
Gravitational
force of
force.
gravity, yeah. But what is the total force from the seat?
from the seat.
Yes.
Total force from the seat.
What is the normal force acting from? What is applying the normal force?
The weight of the person.
No. When you're sitting on the chair,
Yeah.
what is applying normal force to you?
The chair.
The chair.
Yeah.
What about friction? If you tend to move sideways, friction also is there.
Yeah.
So what is the total force? It is combination of normal force and friction. So you call it just one force, call it F, from the chair. Is there anything else?
Well, normal force and frictional force
That's right, but
they're in different directions.
that's right. But here it says the total force from the seat, right? And the friction or normal force, whatever it is, it may be tilted, right?
Uh-huh.
Some friction, some normal. Normally, the chairs are hanging from somewhere, they may be tilted. But that is just one force from the seat, which combines normal and friction. So that's one force, and gravity. Is there anything else? There's one total force from the chair and one force of gravity. There's nothing else. So if you do the free body diagram, you have a certain direction for the force from the chair. And there's gravity. Mg. And this force from the chair, we don't know which direction it is. We give it an angle. Let's say theta. We don't know the magnitude, we don't know the direction. We need to find those. Right? There's no other forces. And this is free body diagram, y, x. And at this midpoint, which direction is the acceleration? Toward the center, which is in the x direction. And as a magnitude of v squared over r. Right? So, if I write Newton's law, what do I get?
So that's F is this is force of chair.
Yeah, I call it F.
Okay.
The total force from the chair is F. We don't know which direction it is. We don't know which magnitude it is.
Oh. Okay.
And there's mg. There's nothing else. There's nothing else that is in contact with the person, right? So, how do I write Newton's law? Because sum of Fy equal to MAy. What does it give me?
Force sine theta.
F sine theta is the vertical component. It's not adjacent to theta. It's here. We use sine. So we say F sine theta equal to, sorry, minus
Minus
mg.
mg, yeah.
Minus mg equal to 0, so equal to mg.
mg.
Right? I need more. Let me see. So f sine theta equal to mg. What does sum of fx equal to max give?
0.
Mg doesn't have x component. Well, but f might have an x component, right?
Yeah, but it would.
So f cosine theta. Wait, squeaking. Sorry. F cosine theta equal to what?
With 0.
No. There's acceleration.
Oh, there is acceleration.
mv squared over r. Right? mv squared over r. I'm having trouble with the markers. Alright. Now there are two equations, two unknowns. How do I solve for f and theta? You see, I don't know f, I don't know theta.
You add them together.
Sorry?
You add them together.
Add them together, what do we get? F sine theta plus f
F
cosine
over
theta.
tangent theta.
Divide them.
Mhm.
Divide the two equations, f goes away. And then get sine theta over cosine theta, which is tan theta, equal to m cancels, g over v over r, v squared over r. So, tan theta, if you divide equation 1 with equation 2 by equation 2. F cancels, get tan theta, m cancels, get g over v squared over r. When r comes out, becomes RG over V squared. So tan theta becomes RG over V squared, and then theta becomes tan inverse of that. Right? Yeah?
If we isolate the M in the first formula, putting the second one in the same answer,
Yeah, you get the same thing. You can isolate F in one formula. M cancels out. Right? If you do the same thing, F also cancels out. There are different ways of doing that, but it comes to the same conclusion. Theta becomes tan inverse of RG over V squared. You can calculate it. And then, how do we get F? Then we use one of these to get F. Something you can do to get F also is if you square both equations and add them together, then it becomes F squared times sine squared plus cosine squared, which is 1 equal to sum of the squares of the other, but it's the same as just doing the other. Right? Now that you have sine theta, you can plug it in here in one of those equations and find it. Alright? And then it says, at what rate in RPM would the passenger feel weightless at the topmost point? In here, remember, what did we find for the normal force? At this top, the normal force was M times G minus V squared over R. Right? Gonna be this squared over R. This is green. So, what does weightlessness mean? What does weightlessness mean?
Means normal force is greater than or equal to or greater than the force of gravity. Or,
Normal force is
or maybe
how do you,
zero?
sorry?
Normal force is 0?
Yeah, that's right. Normal force is 0 when there's weight. You see, you still here, if V is not high enough, we found like for the previous part A. The part A, the normal force was less than mg, less than the weight, right? That is the if you put a scale under you at that position, what do you measure? The normal force, right? Which is less than your weight,
oh, okay.
right?
Yeah.
So weightlessness means there's no normal. So set that equal to 0 and see what speed gives you the normal force equal to 0. And if you remember, if you are in an elevator and it's accelerating upward, you feel that normal force is larger than your weight. Means that you're feeling heavier. And if you put a scale under you, you see you're measuring higher than your weight. If it is accelerating downward, you're measuring the normal force lower than your weight. And if it go at the acceleration of gravity, then you have no weight. Like the astronauts in a spaceship. that's going around the earth. You're falling with the acceleration of gravity at that point. Some people have this misconception and think that there's no gravity there. Yes, there's gravity, but they are falling at the same rate as the gravity. The gravity is just a little bit less than what is on the earth. It's about 9.29, something like that, instead of 9.8. But they are falling with that acceleration. That's why they don't feel weight. They have weight. They experience weightlessness. All right. So if you put n equal to 0, then you get g equal to v squared over r. And you see that means that all the acceleration that you have is provided by the weight. Right? V squared over r is equal to g. You don't need any more forces to keep you on the circle. Right? And then v squared equals to rg. And v is equal to square root of rg. That's the speed. And then you can convert that speed again to RPM. And I need all repeated.
Solid.